In this video we look at measures of central tendency. Measures of central tendency are used to summarize data with a single value. So the idea is that we use one single value to represent an entire set of data. The most common that you've probably seen before are the mean, the median, and the mode. So those are all measures of central tendency is what we call those. I'll just give you a quick recap of what those are, just in case you've forgotten. So the mean is basically the sum of all of the values divided by the number of values. So basically take all of the data points, add them all up, and divide by how many there are. Now we'll talk a little bit about something that's a bit different. We'll talk about a population mean. So a population mean is probably the mean that you've figured out often in the past. You have a whole set of data and we actually calculate the mean of that just like we have done in the past. Take all the data points and add them together, divide by the number. Now sometimes it's impractical to find the mean of the population, so instead we find a sample mean. So basically a sample mean is a mean of a random sample taken from the population. For example, if you wanted to find the mean number of television viewing hours from the students at your school, rather than surveying everybody, you could survey a sample, and then that would be the sample mean. And ideally your sample is chosen so that it is representative of the students at your school. And that's a useful way to do that rather than getting a mean, doing a population mean. We use a couple of different symbols here to represent the different means. This sort of U shape is actually the Greek letter mu, and we use that to represent the mean for a population. We use this X with a bar on top of it, it's called X bar, to represent the sample mean. So this X bar is a sample mean. And again, just to give you the formula here, the population mean, mu, is equal to all of the values in that population added together, divided by the total number of elements in that population. We can write that a little bit shorter, rather than writing x1 plus x2 plus all the way up to xn. This just means the sum of all of the x's, where the x's are the individual entries in your population. And we divide by n. Here the capital letter N represents the number of items in the population. If we want to find a sample mean, exact same thing. So x bar, again, is that sample mean. We basically take all of the entries in our sample, add them all up, that's all of these, and then we divide by n. So notice this case is a lowercase n. The lowercase n represents the number of values in the sample. So that's how we can find the mean. I guess we should move on now and look at the median. So the median value is the middle value when the data is ranked from lowest to highest. So basically you organize all your data points from lowest to highest, and the one in the middle is the median. If there are two data points, then the two that are in the middle are averaged together. So for example, if you wanted to take the median of 1, 2, 3, 4, and 5, that one, in this case, there are an odd number. It's pretty obvious where the middle is. It's right here. We'll talk about how to find that in a second. But if you have an even number of data points, then the middle is actually right in between these two. So we take an average of those two. Now here they differ by 1, so the average is halfway in between them. Is 2.5. These numbers could be anything. You would do the same thing. Just find the average between the two numbers there. So add them up and divide by 2. Now the way that we find the middle might be a little bit confusing. So for example, if we look up here for this this sample with 5 elements in it, numbers from 1 to 5, the middle was right here, and we can see that visually. Sorry, right here at 3, we can see that visually. But we want to be able to do this for larger sets of data, and the way that we can do that is we take the number of data points that are in this set, we add 1 to it, and then divide that by 2, and that will give us the middle number. So in our example, there were 5 data points. 5 plus 1 is 6. Sorry, 5 plus 1 is 6, and we divide that by 2, so 5 plus 1 is 6 divided by 2 gives us 3. So that tells us that we're interested in the third element, and sure enough, that's what we had. In the case here, there were 4 elements. 4 plus 1 is 5. We divide that by 2 and we get 2.5, which means that we want the item between the second and the third element, which is exactly what we figured out how to do. And then the sort of last measure of central tendency that we need to talk about is the mode. That's the one that occurs the most often. Some data points or some data sets, don't have any modes. There's no number that's repeated, and others will have multiple modes. If you're asked for a mode of a set that has multiple modes, you just report on all of the modes. The other thing to consider when we're talking about measures of central tendency are outliers. Hopefully you know what an outlier is, but if not, basically outliers are just values that are far away from most of the data. So if you think about a set of class marks like the one listed down here, if these are class marks, you can see that most of the students in this class are in this 70 to 85 range. There's one that's way, way out, and that's this one right here. So it would be considered an outlier. And the reason why we might be interested in outliers is they can have a big effect on means, but not so much medians. So for example, if you look at this data set, if you were to calculate the mean of this set, you would get an answer of 69. And if you were to calculate the median, you would get an answer of 75. So that 15 is really pulling down the mean. The fact that this is a 15 has no impact on the median as long as the number is below 70. So if this were a 65, the median, if this 15 were a 65 instead of a 15, the median would still be 75 because that number is one lower than the smallest number, one number lower. So in this case, the median wouldn't change, but the mean sure would, and that makes a big difference there. So the outliers have big impacts on the means, but not so much on the medians. Alright, let's move right along here. Let's have a look at some examples. We'll just go through how to calculate the mean, the median, and the mode. So here we have two classes, Class A and Class B, with the marks for each of those classes. We'll find the mean, the median, and the mode for each class. And so to do that, we could start with the mean and go from there. So this is, be careful here, the question does say that each class is a sample. Let me just highlight that because that's kind of important. So each class is a sample of the population. So taken together, the two classes are the population and each class is a sample. And that's just to get you used to using those different notations. So Class A we'll do over here, and we do Class B on the other side shortly. So we want to find the mean. So this is a population, so the mean can be represented by x bar. It's just the sum of the x's divided by the number of marks in the class in this case. So if we go through and add all of these up, I won't write all of them down, but I'll write enough for you to get the idea. So we take 71, add 82, and keep adding until we get to the end. Last one here is 68. And then we have to divide by the number of elements in this set. So in this class there were 17 people. So we go ahead and add up all of those values and we get 1,215. And then we have to divide by 17. And if we do that, we get a mean of 71.5. Okay, so that's the mean. I guess we could do the same for Class B. I'm worried I'm going to run out of room here, but we'll try to squeeze it in here. So Class B, maybe right here. Same idea. The sample mean is just the sum of the x values divided by the number of them. So we'll take 54 plus 80 plus 12 plus and so on, divide by however many. In this case there are 18 of them, so there's one more, and that's okay. And when we do that, we get a total of 1,159, and we're going to divide that by 18, giving us a result of 64.4 for the mean. Now you can see that the mean of this class is much lower than the mean of the other class. We'll talk about that in a moment. So let's move on now to calculate the median. So in order to calculate the median, what we need to first do is to organize the set from lowest to highest. I won't do all of it, but I can get us started here. So the lowest entry in class A is right here at 45. So 45 would be the first one. And then we have a 51 here, so that's taken care of. It's helpful to kind of, I don't want to say scratch them off in case you need them again, but somehow indicate that you've used all of these values. There's also a 55 in the list, and I think you get the idea from here. So you keep going, you organize them all, and so on, and we want to find the median. So don't forget there were 17 sets, 17 pieces of data, or 17 marks in this class. To find the median, we take that 17 and add 1 and divide by 2, and that tells us the rank of the number that we want. So what value are we looking for? So 18 divided by 2 is just 9, so we're looking for the 9th element in this set, and it turns out that the 9th element in this set is number 71. So the median here is just equal to 71. Do the same thing on the other side for class B, so finding the median. And again, just starting here with the list, 12, 15, 44, and so on. There were 18 elements here, so to find the rank that we're interested in, we take 18, sorry, that's a bad looking 8, add 1, and divide by 2. 18 plus 1 divided by 2 is 19 divided by 2, which gives us 9.5. That means that we need the average between the 9th and the 10th entry in the table. And if I'm not mistaken, the 9th and the 10th are both 71. And again, you can double check this, but I believe they're both 71. Or that gives us the average anyway. So we would take the average between those two elements. Clearly they're not both 71 because I'm just looking at the list and seeing that they're not in there. 71 is not in there. But the average between the two, so I wrote down the answer, but I didn't actually write down the two values. So here we would get a median of 71. And that's just taking the average between the 9th and the 10th entry. And I guess we haven't talked about the mode yet. So the mode is the number that happens most often. So if we look at class number 1, there's a 71 here, a 71 here, and another 71 here. So that number happens 3 times, so the mode is 71. If we move over to class number 2, let's see, there is a 61 and a 61. So that gives us a mode. Don't just stop there though, this one actually has 2 modes. It also has 80 occurring twice, so it is also a mode. I've already checked to make sure that there aren't any others. So 2 modes here, 61 and 80. Part B of this question says to compare the performance of both classes. So you can see that both classes have the same median. So the median is the middle mark. So the middle mark is the same for both classes at 71. Turns out that the mode of the one class was also 71. But class B has those 2 outliers that happened, let's see, where did that happen? At 12 and 15%. So 12% here and 15% over here. So those are outliers, and again, we talked already about how those outliers can really drag down the mean, and we saw that here with a mean of 64 compared to a mean of 71.5 with the other class. So 2 outliers, for whatever reason, those marks were really low, but aside from that, the classes are fairly similar. Those outliers do pull down the overall mean. We could also, at this point, I don't think we'll do it just to save some time, but we could also look at how do the means, medians, and modes compare for each class compared to the overall mean, median, and modes. But as I said, I think that's an easy thing to do. You would just find the population, mean, median, and mode, and then compare them to the individual classes, which is something that's sometimes done. Alright, let's move on here to talking about grouped data. Sometimes it's helpful to talk about data that's grouped together. And when we do that, I'll walk you through an example here. Again, this mu represents that population mean. So the mean for group data is approximately equal to the sum of the Fi's times the Mi's. So the F's just represent the frequency. Probably write that in here. So this is just the frequency. And the M's just represent the midpoints. So these are midpoints of the intervals. And we'll work through an example so you can see what that looks like. And the I's just mean for every interval we would find the frequency and multiply it by the midpoint of that frequency. We get pretty much the same formula here for a sample mean, except we're doing it with the sample rather than the total population. So here's an example. We have a group of children. They're asked how many hours a day they spend watching television, and the table here summarizes so we can see that for 0 to 1 hour there was 1 child, 1 to 2 hours 4 children, and so on. So let's walk through how we would find the mean here for grouped data, and then we'll talk about the other measures of central tendency. So first thing that we need to do is I've created a table here. We need the midpoint of each of the intervals. So I've created this table because I think it's helpful. To find the midpoint, we just find the average on this interval. So the average is found just by taking the endpoints of the interval, adding them and dividing by 2. We're just finding the middle. So 0 plus 1 is 1, divided by 2 is 0.5. And we continue that all the way down here. 1 plus 2 is 3, divided by 2 is 1.5. And I think you can probably see a pattern happening here. And these numbers are easy enough that you can see where the midpoint is anyway. Alright, and here's our frequency. This is the number of children for each of the intervals. That's our frequency. And we'll come back to this cumulative frequency column here in a minute. We'll need it in a bit. So in order to find the mean for group data, we need the frequency times the x values, or the midpoint. So we're going to take these two columns and multiply them together. So we'll take that, multiply it together, and so 1 times a half is 0.5. And then here we should get 4 times 1.5 is 6. We'll get 17.5 here, 10.5, and then 9 and 5.5. So again, that just comes by multiplying these results together. The midpoint times the frequency in that interval. So we need the sum of the frequencies times the midpoints. I thought I had that written down already, but I don't. So just give me a second here. We'll just calculate that quickly and see what we get here. And the grand total here, it looks like it's about 49. So I'm just going to write that here as our total so that we have it. So our total here, we said, was 49. Now the cumulative frequency is going to help us actually find the sum of the frequency, so these values right here. What the cumulative frequency is you just kind of keep a tally going of the frequency. So the frequency here was 1. And then we had 4 more added to that, so 1 plus the 4 gives us 5. And then we added 7 more to that, so that gives us 12. And we added 3 more, that gives us 15. We added 2 more, that gives us 17. And we added 1 more, that gives us 18. So this is the sum of the frequencies. There were 18 children in total. It's basically the same as just adding all of these values together. But it helps us. You'll see why shortly, hopefully. So I'm going to stick the mean way up here so that hopefully I have enough room to do the median as well. So in order to find the mean, and this is a sample of children, so this is a sample population, we want to take the sum of the frequencies times the midpoints, and we divide that by the sum of the frequencies. Well, the sum of the frequencies times the midpoints was the sum of this column right here. We had 49, and we divide that by the sum of the frequencies, which was 18, and then 49 divided by 18 gives us approximately 2.7. So we get a mean for our group data of 2.7. Now, I should mention here that I did say approximately, and notice that these equal signs are approximately equal signs. And the reason for that is that because the data is grouped, we lose a little bit of information when that data gets grouped. So this is always going to be an approximate. Even if it worked out to exactly 3, it is an approximation. So we say that and I should probably show that here, put a little approximately equal to symbol here. Because we do lose some information, and it might be a little bit higher or a little bit lower, but it's approximately 2.7. Now, in order to find the median, we need the data organized from lowest to highest. We've already got that in our table. The intervals are grouped from lowest to highest. We still need to find the rank. What's the sort of position in the middle? Well, there were 18 data points. We add 1 and divide by 2, so 19 divided by 2 gives us 9.5. So the middle piece of data, the median, is the 9.5 piece of data. So basically we need to take the average between the 9th and the 10th. So here's where our cumulative frequency comes in handy. We know that at this point there was 1 item. Here we were up to 5, so 5 in total. And here we were up to 12. The 9th and the 10th item appear on this interval right here. So when we find the median is this interval. So we say that the median, is the interval of 2 to 3 hours. Just change my pen color. So the median is the 2 to 3 hours. If one of the data points were in one category and the other one were in the other, then we would take we could take like an average of the two midpoints and call it there in there. That could certainly work. And the mode is a little bit different. Because we're not talking about a single value, we can talk about the modal interval, the modal interval. So the modal interval is the one that happens most often. So which interval had the most children in it? Well, this one had 7. So the modal interval here is also 2 to 3 hours. So that's how we can find the mean, median, and mode when we have a set of group data. So that's a quick introduction, well, maybe not so quick introduction to measures of central tendency. Some of them you've seen before, some of them might be a little bit new, but that's a quick, no, sorry, not so quick. That's an introduction to measures of central tendency.